Alright, so to solve this one, we do need to be careful because we have a secant x in our original equation, and secant x is not defined everywhere, so when we get our answer we will need to check for extraneous solutions. And if you're having trouble getting started with this one, like on the last few questions, instead of thinking of this as a secant x squared, just think of it as a regular x squared. Instead of a secant x, just think of it as an x. And even though this is not the question you're trying to work, it kind of looks more familiar, and it generally the steps that you should take come to people a little bit better. So when you solve in a quadratic, you want it to be all on one side equal to 0, standard position. So that is what your first step here should be. Okay, and then quadratic, you can do quadratic formula or factoring. And if this factors as an x minus 2, x plus 1, this is going to factor as a secant x minus 2 and a secant x plus 1. Feel free to FOIL that out to check it. And the reason why we need this to be equal to 0 and not equal to 2 is this could be 0 or this could be 0, and 0 times anything gives you 0. So then I can figure out where this equals 0 and where that equals 0. Same property doesn't work for 2. I can't just figure out where this could be 2 or where that could be 2. Only 0. So I could set this equal to 0 and solve as well, and I would get 2. Set this equal to 0 and solve, I get negative 1. But it wouldn't be x equals like over here. It would be secant x. So in algebra class, you might be finished, whereas we would need to go a little bit further. I've got to ask myself, where on the unit circle is secant 2? Well, I don't memorize secant values, but I can take the reciprocal of both sides. And take the reciprocal of both sides. And I do know where cosine is a half. And I do know where cosine is negative 1. This is looking like one of the last questions I just did. So let's throw in our answers here. Directions say solve, so we need to make sure we include all the coterminal angles, so not just pi over 3, but everything coterminal, not just pi, but everything coterminal, and 5 pi over 3 plus its multiples of 2 pi n, and n is an element of the integers. That way we're adding the correct amounts of 2 pi. Now, as I said at the start, we do have to be careful here. Just because this solves this doesn't mean that these are the solutions. They could be extraneous. So we need to make sure that these actually solve the original equation. So if you think about it, secant is undefined. Secant is 1 over cosine, and we can't divide by 0. So secant is undefined when cosine is 0, and cosine would be 0 here and here. So if either one of those answers had been one of our answers from our work, we would have to throw them out because they'd be extraneous. They might have solved the previous step, but they didn't solve the original equation. None of ours are going to make that happen, so they should all be fine.